So today we're talking about inverse functions. And just a quick reminder that in math, inverse sort of means opposite. It kind of depends on the topic in math that we're speaking about, but for today, let's say that inverse and opposite kind of mean the same thing. In functions, you always have an input and an output. Quite often our inputs are values that we can plug into our equation or substitute into our equation for x, and the outputs are what you would get for a final number once you've done all the calculations. Well, in an inverse function, the inputs and the outputs simply trade places. So that's kind of what I'm talking about when I mean opposite, or when I say opposite. The inputs and the outputs switch. So function notation looks a little different for inverse functions as well. If your original function is labeled f of x, the inverse function should be labeled f to the negative 1 power of x. This is known as the inverse of f. If my original function was g of x, this would be g to the negative first power of x, or the inverse of function g. It is extremely important to use the correct function notation with inverses. So, important parts to put into your notes today. To find an equation's inverse, you first of all switch the x and y variables. Then we solve, otherwise known as rearranging for y, also known as isolating y, right, getting y by itself, and then replace your new y with the inverse function notation. Let's take a look at how that happens. So here I have a function f of x equals 2x plus 3. This is just a nice little simple equation, but because of the f of x, it's what we call in function notation. So f of x, I'm going to replace f of x with y, so that I just have y's and x's to deal with. And then, like I said, the first step is to have x and y switch places. Now I'm going to work on isolating y. I need to get y by itself. And according to inverse operations, I have to get rid of the addition before I can get rid of the multiplication. So I'm going to subtract 3 from both sides. That's going to give me 2y equals x minus 3. Really, it gives me x minus 3 equals 2y, but I'm going to go ahead and put y on the left. And then I divide everything by 2. And technically this is my inverse function. However, I'm going to do a little more simplifying. I'm going to say and make sure that I realize that that x is being divided by 2, but so is that negative 3. So I'm going to put x over 2, or I could have put 1/2 x minus 3/2. And the last step I need to take is to write this in inverse function notation. Now I know that that looks a little bizarre, right? This bottom function and this top function are actually inverses of each other. The inputs and outputs are going to be completely opposite. However, let me show you another way to look at this problem. Now hang with me for just a minute, because this is going to look a little weird up front, but I promise you this is the easiest way to find inverse functions. Alright, so again, this is y. This is the same as y, so I'm going to put a y here instead of f of x. And I'm definitely going to trade places with the x and the y. So I'm going to get x equals 2y plus 3. And now I'm going to make myself a list using order of operations of what's happening to y. So I'm going to start with y, and I'm going to say that y is, first of all, y is being multiplied by 2. Then it's being added to 3. And then all of that equals x. Now to write my inverse function, I'm going to start at the bottom of my list and go in the opposite direction. I'm changing or using the opposite mathematical operation all the way back to the top. So let me show you what I mean by that. At the bottom of my list I find an x, so I'm going to put an x here. Then I'm going to go to the next step up and I'm going to say, what's the opposite of adding 3? That's a subtract 3, so I'm going to put subtract 3. Then I look at the next step and say, what's the opposite of multiplying by 2? That's dividing by 2. And then finally, the opposite of beginning with y is ending with y. So I can put that my inverse function is x minus 3 all over 2, or like I said, I can split that up and put x over 2 minus 3 over 2. Either way, I get the same inverse function that I got before. But this list, it is amazing to me how much effort and stress that little list can help us avoid. So let's take another look. Here I've got another function. If I try to do this without the list, which is totally okay if you can understand how that gets done, but again, I replace f of x with y and let x and y switch places. Now remember, I'm trying to isolate y, so I need to get rid of the times by 4 and the power of 2. Now in order of operations, powers or exponents come before multiplication. So when I do inverse operations, I need to go in reverse. I need to get rid of this 4 before I can get rid of the squared. So I'm going to divide both sides by 4, and then the opposite of a square is a square root. So I'm going to square root both sides, and I get y equals the square root of x over 4. And then of course I'm going to put this in function notation, and for now that's as simplified as we're going to get. We'll simplify it further another day, but for today that's enough. Let me show you what that looks like with my list. Again, remember this is y, right? F of x can be replaced with y for our purposes anyway. And I change places with the x and the y. That's a squared. Okay. Now I'm going to make my list. Remember, I'm trying to isolate y, so I'm going to start with y. And I'm going to say y is being what? According to regular order of operations, my exponent needs to come first, right? Please excuse my dear Aunt Sally, exponents come before multiplication. So I'm going to say y is being taken to the power of 2, then it's being multiplied by 4, and finally it equals x. So to write my inverse function, I'm going to start at the bottom of the list and start with x. The inverse of multiplying by 4 is dividing by 4. The inverse of a power of 2 is a second root or square root. And the opposite of beginning with y is ending with y. But of course, I would want to put this in inverse function notation instead of writing y. And there's my inverse function. to me, the list helps me make much more sense of this. We'll do a couple more of those in class. I want to do one more with you and show you that inverse functions is a great way to rearrange formulas to isolate a variable. So let's say that I have to take this formula. This is actually the formula for area of a trapezoid. And it's asking me to solve for B1. That means to isolate B1, get B1 by itself. I can use that same inverse function list to help me rearrange a formula. So if I need to isolate B1, I'm going to start my list with B1. And what's happening to B1? According to the parentheses, it's being added to B2 very first. Then it's being multiplied by H. It's also being multiplied by 1/2. By the way, multiplying by 1/2 is the same as dividing by 2. I'm just going to write that off to the side. And finally, that all equals A. Now to rearrange this formula, I'm going to start again with the bottom of my list, and I'm going to start with A. Going up my list, the opposite of multiplying by 1/2 is multiplying by its reciprocal, which is multiplying by 2. Or because 1/2 is the same as dividing by 2, I can see even better that the opposite of dividing by 2 is multiplying by 2. So I'm going to take that A and I'm going to multiply by 2. The opposite of multiplying by H is dividing by H. The opposite of adding B2 is subtracting B2. And then finally, the opposite of starting with B1 is ending with B1. And we just rearranged that entire formula to solve for B1. All right, just a couple of quick reminders. I don't want to overwhelm you. Like I said, we'll go through some more examples in class, but please make sure that you have the steps and the examples written down. A couple of things to know about inverse functions. Remember that the domain of a function are all the x values that can be used in a function. The range is all the y values that are outputs, so the domain is all the inputs, the range is all the outputs. The x values are called the independent variable in a regular function, and the y value is called the dependent variable. Just really quickly then, in an inverse function, the independent, because the x values and y values get switched, in an inverse function, the independent variable would be the y, and the dependent variable would be the x. All right, that's probably enough for today. Like I said, we'll go over this a little more in class. Make sure to bring any questions that you have on the examples that you've already seen, and I will see you soon. Have a great day.